Hey everyone, how's it going? Glad you guys could join us. Give us about 3-4 minutes or so, and we'll probably get things started. Make sure everyone has a chance to sign in. Hope everyone's doing well, staying safe. All right, we'll just get going as soon as I get my windows straight here. Looking good. All right, let's give us a couple more minutes and we should be set. It's great to see everybody.
Hey.
Oops. Don't move. All right. 1 second. All right, let's get one more minute and we'll get started. All right, so I hope everyone can hear me. It's great to see everyone. These DesignSafe webinars are stuff that we try and bring at least a few times a year to try and show you some of the new aspects, the new technologies or new research that's being done. It's always I'm Charlie Day. I'm the Director of Professional Development and Training here at TACC. I'm also one of the training leads on DesignSafe. Make sure we're all working good. There's too many windows open on my machine, so I'm losing the chat. Oh, there it is, behind everything, of course. All right. So a little bit of background about DesignSafe first before we get moving to our topic of the day. So, my keyboard working? Yes, it is. All right, so today's topic is the Hazmapper 2.0. That's DesignSafe's custom application for geospatial data. We have a special, one of our TACC researchers, Mahyar, to present for us today and kind of walk you through on what Hazmapper is all about. So first off, a little bit about DesignSafe itself. So DesignSafe, we have a vision, of course, when we first started this out about 4 years ago or so. We wanted this cyber infrastructure to play an integral and dynamic part of your research discovery. The idea was to put together a lot of cloud-based tools, useful cloud-based tools that support your data analysis, that supports your visualization, supports integrating different diverse data types, to be able to, essentially what we like to say, unlock the power of big data. All right, so what exactly does that mean? Your data tells a story, all right? Your data, it's a story that you want other people to understand. And unless you can get all your data in one spot to analyze it, you're not gonna quite understand what that big story is, and you're not being able to relate that story to other people. So that's what we mean by unlocking the power of big data, finding out what that story is so you'll be able to present that to other people. Whoops, wrong way. All right, so the idea is basically we want to support the end-to-end research workflow and the full research lifecycle. So what we mean by that is everything from you conceptualizing your research project to building it out, to doing the studies, doing the data, collecting the data, analyzing it, and then of course publishing it, to the point where now you collaborate with other people and they then take your data and then they can just, it basically get inspired to find other stories or other ideas from that data set. And essentially this trend continues. So we want to be able to build DesignSafe to support that end-to-end research workflow and that full research life cycle. And of course, we want to enhance, amplify, and link all the capabilities of the other NERI components and be able to essentially offer them to you as one big resource. So how exactly are we enabling research? For those of you who are new to DesignSafe, essentially how DesignSafe is built, we have this thing called the DataDepot, where all of the data resides in, all of your data sits in. And then we have what we call the Discovery Workspace. What that's all about is that is where we have our data analysis tools, our visualizing tools, a bunch of shared application and scripts throughout the community. And they essentially run their data analysis or run their simulations, and that gets saved to the DataDepot. And then of course we have other means feeding of the DataDepot as well. We have your simulation research, we have your experimental facilities, and then we have what we call the rapid research as well. And from reconnaissance data to sensors and data image collection, data collection, to models being ran and data being created, all that can feed into the DataDepot. Now, once it's in the DataDepot, we have tools to help you curate and then publish. All right. So essentially, you're not just publishing research papers now; you're also publishing your data sets. So the data creation philosophy is rather simple. We basically just want to allow users to easily store and share their data sets, right? And being able to essentially publish the data throughout the life cycle of a project. We really want the data models to be flexible. So we understand that there's lots of different scientists who are using our systems. The way you manage your data versus the way someone else manages their data could be very, very different. You have different layers of what we like of data structures that you put through. So we want to be really flexible. We want to allow researchers to decide how to best represent their data and how the data best represents their researchers. We need to consider what's needed for data to be understandable by an outside user. This is that story I was trying to tell you about. You want to be able to relate what that story is to other people as well. And then be able to define categories for how your data sets connect together. They're usually user-defined for experimental data, so you have model configurations, sensor info, events, analysis report, etc. But they're customizable. So these data models that we're creating, they have to be able to support experimental data, simulation data, other types of data that we haven't actually categorized yet, hybrid simulations, field reconnaissance. Social sciences are now coming up and using DesignSafe. It has to be kind of open. So the data sets have to be open to be able to be understood by the rest of the community. One thing we've done at TACC to be able to manage that is we have a data curator on site, Dr. Maria Esteva, and she's actually a really great person to work with. And she actually does open office hours on Tuesdays and Thursdays at 1 p.m. With that DesignSafe address there. That's also actually on DesignSafe's website too. So if you have questions on how to curate your data, questions how to categorize your data, or what best methods are available to do those, to apply that to your data sets, Maria would be more than happy to answer those questions and walk you through the process to get your data to a good, solid state. It's actually rather easy, but the basic steps are you define your category tree. So you define how the data is laid out. In this case, we have a model config, a sensor, and then an event. And then essentially, we then assign files to those categories. And so we take the file, we basically say what category that file goes under. And then essentially what we do is we publish those projects and those files. And once you publish it, you get this DOI. So now you can include that DOI and cite, your data can then be cited, and then it can be, that citation can come back to DesignSafe and back to your project. So like I said, we do have a Tuesday, Thursday Zoom meeting with Maria. If you have any questions at all, hit the DesignSafe website and she'll be able to help you. All right, so there's various ways, of course, we need to get your data from wherever it is currently sitting on your machine or in a box or on a bunch of floppies. But the idea is to get that data to DesignSafe. So there's a lot of different routes to do that. You can use the DataDepot, and you could, or you can upload directly through Jupyter Notebooks. There is a small caveat there that it's a relatively small number of files, so about 25 files or so, and relatively small size, about 100 megabytes each file. You can also go through box.com, Dropbox, or Google Drive. You can connect that to your DesignSafe account. And then you just update and then sync it from the desktop folders to Box, and then come into DesignSafe and then pull and copy those from Box, Dropbox, or Google Drive into DesignSafe. If you have a large number of files, greater than 25, greater than 100 megabytes, Globus is actually the best route to go. It takes a little bit of work to get it connected into DesignSafe, but we do have the data transfer guide, and we have the Globus data transfer guide. Each one of those will give you information on what the steps are to get Globus connected to your DesignSafe to be able to get your data across. And of course, for the people who are a little bit more comfortable using command line, there are command line options available as well. The rsync and SCP are two ways to be able to use the command line and get your data across. All right, so this is kind of what we're trying to push about. So you have your data sets, you have them in DesignSafe. We really want you to make your data count, all right? That means we want you to formally publish data sets in a stable data repository. And by data process, and including the data processing scripts that you use, any visualizations that you ran, etc. Right? The data needs a permanent location and a digital location. So that's where the DOI is going to go to. And the DOI is not just a URL that connects you back to the data set. It's essentially a listed curated data sets that you essentially can, it's telling you where the data is being held at. So listed curated data sets, essentially you can put that then in your curriculum vitae. And then of course, you and other people who use your data set, you can then formally reference that DOI from any paper or any publication. All right, so you set up a project. When you're ready to, when you have it published, all you do is you click the citation button, and it gives you essentially the citation for that data set that you can then copy and paste into your document. All right, so that's a little bit about DesignSafe, a little bit about how important your data set is. And so with that, I'd like to introduce Mahyar Sharifi. He is a PhD here at TACC. He is one of our researchers, a research associate, and he's got a background in mining engineering and civil engineering. His research focuses on regional landslide and lateral spread and hazard mapping, and he was one of the driving people at TACC on how Hazmapper has to be developed and what aspects of Hazmapper is going to be important to the community. So with that, I'm going to hand this off to Mahyar, who's going to be able to walk you through the Hazmapper 2.0 application for DesignSafe. All right, thanks, Mahyar.
Sure, thank you, Charlie, for the introduction. I'm gonna share my screen now. Okay, so hopefully you guys can hear me good, and as well as see my screen. Okay, so hello everybody, and I hope everyone is all right and staying safe. Today I will be presenting DesignSafe's Geospatial capabilities, and I will be going over the Hazmapper 2.0, the newly updated application in DesignSafe developed by our mobile and web application teams at TACC. Hazmapper is actually a web-based application, and it is used for visualization and analyzing geospatial data in a variety of formats. It essentially allows researchers to create maps and share the maps with their peers through the DesignSafe DataDepot. In this presentation and webinar, I will also present our latest data model for publication, which is the field research data closest data model related to the visualization of the geospatial data sets. So Charlie did a great job explaining the visions of DesignSafe. I'm going to add and build on to that in terms of and speak in terms of the field research that will usually happen after a natural hazard event. So our cyber infrastructure is an integral part of your research. It contains cloud-based tools that supports visualization of geospatial data as well as simulation and other types of applications. So in terms of rapid research or field reconnaissance research, usually this includes remotely sensed data in the field associated with metadata and the planning documents for that mission. Whether the field reconnaissance is completed through the NEARI rapid center equipments or such as like the RAP app or separately, in both cases, the data can be transferred into DesignSafe DataDepot. In terms of a rapid application, RAP app, usually this will happen automatically through the application, or in the other ways, as Charlie mentioned, you will be using one of the methods of file transfers into DesignSafe DataDepot. Once the data set is there, you will be able to use the discovery workspace using various shared applications, including the data analysis and visualization tools, such as Jupyter Notebooks or the Geospatial visualization tools such as QGIS, Hazmapper, and other things to work on your data and analyze your data in the cloud and save your work back into the data depot for further sharing the work with your peers, as well as moving on when you're ready to curate the data set and start publishing that data. One of the DesignSafe components is the research workbench, where the data depot and the discovery workspace reside. The data depot is where all your files are, and where your files are actually stored. It contains my data, which is only accessible to you, my projects, which is shared by shared between your group of researchers involved in a project, and published projects which are curated and has DOIs and community data, which contains uncurated data sets shared with natural hazard community. On the other hand, there is the discovery workspace, which is a place for you to do your research. There are several types of applications that exist in this workspace. It has computational simulation codes, such as TACC for storm surge and hurricane simulations, or OpenSeas for simulating the static and seismic response of structures and geotechnical systems. It has also the data analysis tools, as I mentioned, and the visualization tools in the cloud, such as Poetry for visualization of the point clouds, Hazmapper for visualization of the geospatial data sets, and QGIS for analyzing complex geospatial processings. So in this webinar, I'm going to focus on the geospatial capabilities of DesignSafe and showcase how to use these applications in DesignSafe. Before we get to the Hazmapper, I'm gonna talk a little bit about these two other applications that we have in the workspace. The first one is the QGIS, or Quantum Geographical Information System, which is an open source software for creation, visualization, and analysis of geospatial data. A variety of geographical information data sets are actually stored in a vector, such as shapefile or mapping or as well as raster formats like GeoTIFFs, images and grids, which all can be represented on maps. QGIS is very powerful and a very useful tool for analysis and visualization of reconnaissance data and in natural hazard research. It can be found under the workspace in DesignSafe under Visualization tab, and you will have to simply fill a form by submitting a desktop resolution that you will want for your interactive session, as well as a unique job name, and you will be able to connect to your interactive session. It runs through a VNC session in DesignSafe, and also the QGIS, like in this example that I have, this is a visualization of TACC storm surge output. The layer is actually the maximum water elevation output, which is visualized as a shapefile in QGIS. So in this particular case, using QGIS, you would be able to add more other layers, such as building informations, as well as digital elevation models, and to further process the inundated buildings as a result of this hurricane and storm surge. Moving on to the next application, which is the Poetry application. It is a free and open source WebGL interface for visualization of LiDAR and SFM point clouds. So for those who may not be familiar with it, LiDAR is light detection and ranging. It's essentially an instrument that sends laser pulse to surrounding areas and captures the time that it takes for the laser to get back to the instrument, and with that it will compute the distance, which is essentially result into modeling of the surrounding world in 3D. And a structure from motion is a computer vision algorithm that is used on a variety of pictures taken from an object to reconstruct the object in 3D with point clouds. Both of these will essentially result into point cloud files. Generally, these point cloud files are in LAS format. There are other types of point cloud formats, but the non-proprietary formats are LAS and the compressed version of it, LAS. Both of those types of files can be converted in Poetry application. The first component is Poetry Converter, which converts the point cloud data into the Poetry readable formats, and the Poetry Viewer, which is essentially the renderer that visualizes the point cloud in the web browser. In DesignSafe, you will be able to find these applications under the under Workspace, under Visualization tab, and for the Poetry Converter, you will have to fill out the form and submit the form to submit your job. It needs you to pass a file and a LAS file, or if you have a folder containing multiple LAS files, you will be able to pass that as well. The data sets should be residing in DesignSafe DataDepot, and then you will be able to pass any extra arguments. At the very least, you will have to pass this -p index, which is to create the HTML page needed to visualize the Poetry, and give it a job name, and you will be able to start the conversion. Next, once you have the process of converting point clouds is usually it may take a while, but once it is finished, you will be able to find a converted folder in the same path, and same path as your input file, and you can actually move that. You can actually move on to Poetry Viewer and pass that in here, that converted folder, and give it a job name to submit. And that after a while, you will see a dialog pop up that says your application is ready, and you can connect. To it, and which is essentially allows you to visualize your data set in a renderer, Poetry renderer in 3D. These type of jobs through job submissions through Poetry will allow you to select, will give you a URL which is good for 48 hours, and it's shareable, but it's only good for 48 hours. It's not permanent link. If you are interested to create permanent URLs, you will have to use Hazmapper visualization of the point clouds instead of the Workspace application. So in this particular example, here is a visualized LiDAR point cloud data set that is using in Poetry. The data set is for LiDAR scans of reinforced concrete building performance following the 2015 Nepal earthquake, which is published in DesignSafe, and it can be found under this DOI. So the poultry, actually, the presentation of large point cloud data sets in web browser is actually achieved with a hierarchical tree-like structure that stores subsamples of the original data at different resolutions. So a low resolution is stored at root node, and with each level, the resolution gradually increases. This structure allows poultry to kind of like cut the regions that are outside of the view frustum, and it allows to render distant regions at a lower level of details. With that, now I'm going to move on to the Hazmapper 2.0, the main topic of our webinar today. This application is recently released and it's completely redesigned. It can be accessible through visualization tab under Hazmapper 2.0, or you can actually use this URL directly to get access to it directly. In both cases, you will need your DesignSafe account to log in and start using that. I have to mention that this application is recently redesigned, and you will essentially, once you're starting to work with the application, please let us know with any features that you may want in the application so that we can work with you to better serve your research needs. So Hazmapper 2.0 is a web-based application, and it uses Leaflet API for visualization of geospatial data containing field research assets in a variety of formats. Currently, the application supports GeoJSON files, geolocated and geotagged images, whether they are JPEG or like other formats, videos and GPS track files, as well as the point clouds, which I'll get to that afterwards. As I mentioned before, the maps can be created under Hazmapper, and it can be shared with other researchers as well. Here is the interface of Hazmapper 2.0. It's an interactive map viewer for field recon datasets. You can see in this particular picture, you can see a point cloud dataset that is shown on the map with its bounding box. To the right, users can click view and essentially see the 3D point cloud data in the poultry application in a permanent URL, which can be shared with other researchers. So let me just introduce the interface components of Hazmapper before we actually dive into a live demo of the Hazmapper application. The first component is the add or switch map, add and switch map, which allows you to create a map and then switch around the maps that are created from this dropdown. Next is the point cloud, which essentially create a point cloud feature or a placeholder on the map, and it allows you to add last files to it, which starts the conversion process for you. And once that is complete, it will create an asset of bounding box on the map, which can be found under assets. Which is essentially the next component. This table, this asset button essentially is a table of content or a list of all assets currently shown on the map. The next one is the layers, which allows you to switch the base map and add overlays. There is a filter button which gives you the capability to refine the displayed assets, currently displayed assets in the map to a subset of your particular interest. Next is the manage button, which where you can share the map with other DesignSafe users, as well as to remove the map in case it's needed. And you will also have coordinate information for your mouse over on the right. So with that, I would like to point out that we have our user guide, Hazmapper user guide, which can be found under this URL. And let me now navigate through here to show you where we can find the Hazmapper application and provide a live demo. DesignSafe Research Workbench, DataDepot, and Workspace, the two components that we discussed. Under Workspace, as we mentioned, there are a variety of applications types, simulation, data processing. We are interested in this webinar regarding a visualization, and we are interested in the Hazmapper application. You can refer to the user guide as well to get to know a little bit more about the application and how it works. In here, I'm gonna present a live demo on the Hazmapper. So once you click launch, you will be asked to provide your username and password for your DesignSafe account, and then you will be able to log into your Hazmapper application. So this in here, once again, on the upper left, there is this green button that allows you to add maps. In here, you will essentially have two methods of creating a map. First is the standard map, which essentially only asks for you for a name and a description, and then from DesignSafe project or wrap app that allows you to select a folder that is residing in DesignSafe DataDepot as your map. The difference between the two is that if you select the DesignSafe project or wrap map creation, it will automatically start to importing all of the files that are located in that particular folder, and every hour it will also fetch any new files that are added to it. So think about it in terms of a wrap. For example, if you're working with Rapid Center, wrap will stream the data set that are captured in every kind of like hour, and in here the Hazmapper, if a map is created for a folder that is related to that, you will be able to see them files every hour updated on the map. But I'm gonna just create a map here for our test map here for our and visualization. I'm gonna provide a description of visualization of geospatial data sets. So once I do that, a test map will be created along with other maps that I already had in here. So right now under assets, as you can see, I don't have any particular feature added to the map. I would be able to import from DesignSafe. So when I click import, I have access to my data and essentially all components of DataDepot. My projects are all listed here, as well as the published data that are curated data sets in the DataDepot, and also the community data. So in this particular case, I'm interested to look at a particular file, which is which can be found under here. So, for example, I have a picture of my field survey that is geotagged, and I would like to import that particular image to my file. So as you can see, there is a import file, import started, which essentially shows that the process is started. And once that is complete, you will see your map, see the file on the current list of assets. So in terms of like larger data sets, let's take a look at the adding a GeoJSON file. So I have in this particular map, I have already added a GeoJSON file which contains a variety of pictures. So this particular case is for a steer project for the building assessment of after Hurricane Harvey. So you can see that that GeoJSON file that I uploaded contains in this particular map contains a variety of pictures as well as all of the metadata that can be found under this particular box here. So for this particular image, for example, or point, I can see that there is information about the building address as well as the damage descriptions, damage modes, and whatever other types of information that are stored with this data set, this particular point, all of those will be written here as well. You will be able to download the pictures and essentially you will be able to work with the data set that are here in that sense. So with that, now I would like to point out that you will be able to visualize point clouds as well. So under point clouds, you will be able to add a placeholder where in here, you will essentially click create a point cloud. You will give it a description of your choice. In this case, I'm gonna say Alaska rock slope. So there is this data set that has been captured after Alaska Anchorage earthquake, and you can pass any additional conversion parameters. There is no need for you to pass the -p index here because that's already passed into. So any additional parameter, if necessary, you can pass here. For example, if you want to add any projection to your file or something like that. So once that is complete, you can click here and select add last file to this particular point cloud. So for that, I have my data set under one of my projects here. It's actually this one. So I'm gonna select that, and once that is selected, you can see that the import file is in the process. The next is that it's starting running the poultry converter for that point cloud. So if you click here, you will see that the processing status is running, and the file is the one that you selected. So you will be able, after it's completed, you will be able to build on to this one. If there are multiple last files or multiple other point cloud files, you will be able to add to this particular file, or you can select all of them at once in the beginning when you were selecting the last files. This may take a while, so in the meanwhile, I'm gonna focus on this other point cloud that is already completed. So in this one, it's I've completed it beforehand. The process status is finished, and it was a SFM point cloud data set completed near the University of Washington. So you can click on that. You can see that an asset is happening, is actually added in the assets list of tables, which contains the bounding box. And you can actually interact with the data set here, as well as you can click view, and which essentially directs you to this URL, which is permanent, and you would be able to share that with other researchers when you're working with your data set. So this particular data set is a SFM point cloud captured by UAV, camera-mounted UAVs, and you will be able to use these data sets to, you will be able to use Poetry to measure, to do measurements, create height profiles, as well as other types of things that you can do. So I think at the same time the other feature is already added. So this is for, as if I go back, like if I zoom out, you can see that the data set is actually in Alaska. The other one was in Washington, University of Washington. So I added two different data sets to this particular map. So this particular data set is actually here in near Anchorage, Alaska, in one of the highways. And if I view this other data set, you can see that it's a LiDAR scan this time of a rock slope that was surveyed after the Anchorage earthquake. So researchers, right now, this one, as you can see, there are some holes in the data set, because this particular data set is only one last file, and it's only from one one scan position. Usually you would add multiple last files that are from different scan positions to fill in the gaps, and you will researchers would be able to further process the data set and find out useful informations, as well as such as erosions or any movements on the rock slopes, and so on. So yeah, besides that, for example, this is another data set that I wanted to point out. This one is from the data set from Ridgecrest earthquake in California. You can see that the data set contains multiple point cloud files, as well as pictures of fault ruptures and fissures and crackings that are happening along that. So this particular, for example, data set, you can see the pictures of crackings that are happening, and fault rupture scarps that are happening in here. And actually, these are the pictures. So if you want to visualize them in 3D, the data set actually contains the data set actually contains the point cloud captured from an SFM. So in this case, the same pictures that you are seeing, this is the 3D point cloud. You can see that this is the trace of the fault that is happening from this road all the way to, you can see the effects of this particular point cloud. Let me change this item. That shows a cracking happening on the ground. So you would be able to do measurements of the like this vertical movement, as well as passing a height profile. So let's just do that. If you want, you can pass like something like this, click 2 points, and then you will be able to add a height profile, which can be found under objects profile, and you will be able to see that in 2D. Right now, the data set is, I have to kind of like select an area where the points are denser, but you can see that the profile is actually showing the scarp that is happening in here. So this one might not be a very good example. Maybe I can take another one here. Yeah. So this one is another profile that is completed, and you would be able to see that as well in here. So right now, I think the data set is just doesn't have enough points on the ground as a resolution. So if I try that again, I would be able to see that on a different type of data set. So with that, I'm gonna move on to another type of example. So you can see that another types of data sets are captured. Typically, these are completed as a work of various researchers. So you would be able to bring multiple GeoJSON files from different researchers. So this particular data set shows like a total of like 1,000, more than 1,000 pictures that are captured after the Ridgecrest event. So and this is essentially contains of two GeoJSON files from two different researchers. They can all be combined here. They can be combined and export to GeoJSON file, which allows you to later share that map with other researchers. So with that, I would like to also point out that you will be able to visualize the if you want to kind of like filter out your data sets, you would be able to do that under filter. For example, I just want to look at the point clouds instead of the pictures. I can just click here, and then only the point clouds are listed here under filters. You would also be able to change the base map in terms of like if you are interested in looking at the satellite imagery as well on the map, you would be able to change the base map. In there, under manage is where you would be able to add other team members by just essentially typing like their DesignSafe username. So if I want to add someone, like I can just type their username and click add, which essentially effectively adds that member into this particular map. That member, when like in this case, Nathan, for example, they can kind of like opens his Hazmapper application and find this Ridgecrest project under the drop down of their map of his map. So once again, another thing to point out is that GPS GPS tracks also can be visualized. So remember that if you have a GPS track, you would be able to visualize that as well. So with that, I'll get back to here to talk a little bit about the data curation and publication, and as well as the as well as our recent field research data model. So as we discussed before, the idea here is to the idea behind the data curation is to allow users to easily store, share, and essentially publish their data through the life of their research project. The data model in DesignSafe are structured but yet flexible, which essentially allows the researchers to decide how they want to represent their research data. Remember that with the flexibility comes responsibility, so you will have to work and find like the best way to tell your data story, and we encourage the researchers to consider what is needed for their data to be understandable by other researchers for data reuse. So in this slide, I've pointed out the 5 different data models that we have in DesignSafe. It's experimental project, simulation, hybrid simulation, and field research project, as well as the other. For the field research project, it's for the works that are completed by observation in the areas affected after a natural hazard event. And other project is essentially for any project that is that cannot be kind of like fitted into any of these other data models. For field research data curation, you will essentially define missions and collections and assign file and folders to these collections. You will be able to later relate these collections to missions and relate the collections to missions and so on to organize your data set. So I'm gonna show that by in case of an example. So in terms of a field research data model, the example that I chose is actually can be found under this DOI. It's this particular project captured perishable data from several rock slopes, as you saw one of the point clouds data sets earlier, that are highly susceptible to rockfall that were affected by 2018 Alaska Anchorage earthquake. The objective was to compare in this particular project, the objective was to compare the rate and frequency of rockfalls occurrence, and which essentially the data set was used for post-earthquake recovery and seismic resilience. The way that these researchers decided to organize their they decided to organize their project under the field research data model was to create a single mission that contains 4 temporal collections of engineering geosciences collections. As you can see, they went back 4 times to the field to instrument their data set to instrument the field with the LiDAR laser scanner to capture the rock slopes. They also have a research planning collection in their data set. Usually with any mission comes with the metadata information such as the event as well as the authors, the date of missions like site locations and the DOI itself and the license that are associated with that mission. The collections, on the other hand, each has their own information as well. Like in this case, this engineering geoscience collection, we have 4 different types of collections. First of all, the research planning collection, engineering and geoscience collection. For social science domains, you will be able to create the social science collections and also document collections that have their own DOIs, which essentially includes instruments and reports such as virtual reconnaissance, field assessments, and so on. So as I mentioned, the collections themselves have their own metadata informations. In this case, the observation types was the field sensors and it's geotechnical. The dates of collection for this particular collection is stated. the data collectors are listed, which is not necessarily similar as to the authors of the project. Site location is given, and so on. So these are the metadata information that are most useful, as well as an information related to that collection. Then you will be able to assign the files to these collections. You select your files and assign it to your collection, and later you will be able to relate those collections to your mission, which is essentially, if this data diagram shows the diagram of how this project is actually organized. For any published projects, other user would be able to use our workspace to visualize any of the data sets that are published through the means that we discussed earlier in this webinar. So once again, remember that to make your data count, essentially we want to I would like to point out, to make your data count using DesignSafe, you can formally publish your data set in a stable data repository. And this is not just your data set, it can be your visualizations, your maps, created maps, your scripts in Jupyter notebooks, and other types. They all will reside in a permanent location, digital location, or DOI, and you will be able to cite your data in your reference list of any paper that you are writing, any research paper that you are writing. So to conclude this webinar, I will have to specify once again that the Hazmapper 2.0 application is completely redesigned, and it is in its earliest stages. We highly encourage users to get acquainted with the application and let us know their recommendations, comments, issues, and problems, as well as any feature requests as they work with the application. This can essentially best achieved through submitting a ticket in DesignSafe website, or feel free, if you want, to send me an email with any question that you may have while working with this application. For those who may need help with their data curation, we offer the virtual office hours every Tuesday and Thursdays. With that, I would like to thank and acknowledge Nathan Franklin and Joseph Meering, our Hazmapper developers, as well as the rest of DesignSafe developers. So I would, yeah, essentially with that, I'm going to close and get this back to Charlie, and let me know if you have any questions.
So, hey all, thanks so much, Mahyar, for taking us through that. And of course, you know, we really want to try and let you understand how important your data is and how important your data is to DesignSafe and to the DesignSafe community. One thing I want to touch on before we leave is I want to tell you all about our DesignSafe training archive. So I'm going to share that with the URL up there as well. Hope you guys can see that okay. So the DesignSafe training archive is where all of these DesignSafe webinars are housed at, along with the links for the slide decks and for some of the demonstration software and scripts. So if you need anything, hit the DesignSafe Learning Center and go to our training archive, and you should be able to find all the information there. Of course, you can also hit us on Slack, email us at training, or fill out a ticket. One thing that we're trying to push as well is DesignSafe is a community. If there's some interesting research that you've been doing on DesignSafe, or an interesting tool that you've come across that you're using with DesignSafe, we would love to hear about it. I think it's a great opportunity for maybe you to even present a webinar to the rest of the community to tell them how exactly DesignSafe is working with your research. All right, if there are no other questions, feel free to call us afterwards. But if there are no other questions for this or any other questions from Mahyar, I think we're good. So the chat, if you have a question, use our chat window, or go ahead and unmute your mic and ask us. Okay, doesn't sound like we have anything. Hey, thanks again, Mahyar. Hope you're staying safe. Hope everybody else stays safe. And we'll see you next time. Thank you very much for joining us. Have a great afternoon.